going to discuss about derivation of vorticity equation, scale analysis of vorticity equation and physical significance. Vorticity is derived when a point in atmosphere is of interest, so the basic equation is used to derive vorticity equation is. Here, the derivation is derived from horizontal vector form of momentum equation. The given horizontal vector form of momentum equation written as in zonal and meridional form. This equation represent zonal momentum equation, whereas this equation represent meridional momentum equation. This represent as local rate of change of zonal and meridional velocity component. Yellow color noted variable represent as advection. The left side blue terms represent as pressure gradient force. The green term represent as the Coriolis force. The last term shows friction force, sometimes we refer as viscous force, while dealing with fluid. Now, differentiate equation 1 with respect to y, whereas, second equation, differentiate with respect to x. After differentiation equation 1 with respect to y and equation 2 with respect to x, we get this result, so remember that after differentiation equation, 1a is subtracted from 2b equation. The final subtracted value is arranged below. Now here, we adjust the variable inside the brackets. So here some terms get cancelled out. Variation of Coriolis force and zonal is negligible. Now arranging each term from square brackets, to get our result. Replace the relative vorticity term and divergent term, by the zeta, and d. By arranging the equation we get final relative vorticity equation. This term represents a local rate of change of relative vorticity. This is horizontal advection term of relative vorticity in zonal direction. Here, this is also horizontal advection term of relative vorticity, but in meridional direction. It represents vertical advection of relative vorticity. It is meridional advection of planetary vorticity. This term is referred as tilting term or vortex term of velocity, which formed due to velocity gradient. This term is solenoidal term, which occur only in baroclinic atmosphere, and absent in barotropic atmosphere. Well, this term is divergent term. And the last term we know that, friction term. We done scale analysis of vorticity equation, we get a very important result when keeping the largest term, and neglecting small one. We get this final evaluating term. But what is physical significance of this term? The purple color term represent horizontal advection of relative vorticity, and its significance listed below. The blue color term is meridional advection of planetary vorticity, here local relative vorticity change due to advection of the planetary vorticity. The last term is divergent term, which affect on local relative vorticity, by means of convergence or divergence of flow.